Hey there, welcome to this session. In this video series, we are building our knowledge of embedded systems step by step. In today's video, we are going to understand UART, one of the most important communication interfaces in embedded systems. So, let's start. What is UART? UART stands for Universal Asynchronous Receiver and Transmitter. It is a hardware communication protocol that allows serial communication between devices. UART is one of the simplest and most widely used communication protocols in embedded systems, and you will find it everywhere. So let's quickly go through the most common applications of UART. Debugging and logging. One of the most common uses of UART is during development. Developers send debug messages from the microcontroller to a PC terminal using UART. It is simple and very effective for printf style debugging. Device to device communication. UART is used to interface, communicate with other devices like USB, GPS, GSM, Wi-Fi, Bluetooth, and many more. These modules send and receive data with the microcontroller using UART. So, sum it up, UART is everywhere from development, debugging to module communication to industrial and consumer electronics. It is one of the most essential communication methods in embedded systems. Now, let us see how UART works. Here is the simple version of UART pins and signals. It has a transmit line, a receive line, and a ground pin. UART manages the serial data transmission and reception between the master CPU and either the I/O devices or its controllers. There are different modes of operations in transmitting data between two devices in UART protocol. One-way direction. In this scenario, it will have one pin for data transfer. Second mode, both directions but one at a time because they share the same transmission line. In this case also, it will have only one pin for data transfer. Third, both directions simultaneously. Now let us look at how UART transmit data in the bus. It will have a start bit to indicate a data transmission started and a series of data bits and then a series of stop bits. So this is how a transmitter or receiver communicate the data between the devices. So what are the key functions of a UART driver? So this is where the software programmer actually developed the code for the UART device. Mainly the first one, initialization. So driver has to set the baud rate, stop bits, data bits, and the parity. Then the driver must have the implementation to transmit the data, sending data from microcontroller to another device. Then it will have a receive data functionality, handling incoming data and storing into buffer. Then one of the main important portion of the driver is interrupt handling. Then error handling, detecting and reporting the frame errors, parity errors, or buffer overflows. Let us also look at the actual driver source code. This will help you to understand the UART software implementation better. So here is the link to the source code, mainly the Atmel UART, driver sources from Linux tree. So this is the Atmel UART driver sources. I'll just pinpoint you in some of the sample places, but you can go through this offline in more details and try to understand the driver better. So this is the read function of the driver, which reads the data from the UART device. So this is the write function. Similar to read, this writes the data to the UART device. Similarly, you can find other functions init, close, and interrupt service routine in this file. So in summary, the UART driver is the bridge that connects your embedded hardwares with the UART communication hardware, handling configuration and data transfer and errors. It is simple but extremely powerful and forms the backbone of many embedded communication systems. Hope this video helps you to understand UART communication systems in embedded systems, the backbone of many embedded communication systems. Thank you for watching. Meet you in another learning video on embedded systems.